Okay, I'll keep us moving here. So, as mentioned before, my name is Dane Elmquist, and I serve as a conservation cropping outreach specialist for the UW-Madison Extension Crop and Soils program. Today, I'm going to give an overview of the Wisconsin Cover Crop Citizen Science Network and highlight some of the project's results. I'll also introduce and showcase the project's online interactive data dashboard and provide some details on how to participate in the project for the upcoming 2024-2025 season. So this is a great project led by an outstanding team of people. I'm quite new to the project team, so before I begin the presentation, I really want to acknowledge this core group who have really been foundational in conceptualizing the project and really have built it into what it is today. That group includes Merle Ingram of the Michael Fields Agricultural Institute, Daniel Smith, UW-Madison Nutrient and Pest Management Program, Ricardo Costa Silva, the Nature Conservancy, Greg Sanford, UW-Madison Department of Agronomy, Dave Evans, our data guru of Evans Geospatial, and Dan Marzu of the UW-Madison Nutrient and Pest Management Program. The institutions shown here on the bottom of the slide have also been really crucial in encouraging the success of this project. So I'd like to thank them as well. All right, so onward. So as many of us in the audience are probably aware of, Wisconsin farmers are increasingly interested in planting cover crops and altering kind of the business as usual crop rotations to allow for improved cover crop growth and establishment. And the Wisconsin Cover Crop Citizen Science Network is a farmer citizen science project that was designed to support these cover cropping efforts. So the network began in 2020 to address the need for locally relevant information on cover crop selection and establishment. It involves a team of university and community researchers that have partnered up with groups of farmers to collect data on cover cropping and other conservation cropping practices across the state of Wisconsin. So the project really has two major objectives. The first is to generate more geographically distributed data on cover crop performance in the state. And the second is to really build an understanding of farmer decision-making around growing practices, barriers, and motivations for cover cropping. So the data collected from these working farms is being used to gain a long-term regional understanding of successes as well as challenges of adopting cover crops. And it's going to be used to improve decision support tools like SNAP Plus, as well as guide ongoing and future University of Wisconsin research efforts. And with feedback from farmers, the project has continuously evolved and improved over time. And I'm happy to say that we are currently headed into our 5th year. So I've kind of thrown the term citizen science out there a few times now. Citizen science can basically be defined as the voluntary participation of members of the public in conducting scientific research. So citizen science projects really rely on members of the public to generate data that would, otherwise be really difficult or, almost impossible for researchers to collect on their own. And since farmers are continuously generating knowledge from ongoing experiments and gathering data and applying that knowledge and information in trial and error studies on their own farms, this is an excellent group to engage with for an action-oriented citizen science project like the Cover Crop Network. And the participatory nature of the project has been really crucial to its success over the years. So farmers have been involved from the conception of the agronomic survey through data collection and feedback on annual reports. So really everything we know, stemming from this project is because farmers across the state have stepped up to participate. And the citizen science method is not only great for data collection and knowledge co-production between farmers and researchers, but it's especially useful to learn more about the context within which Wisconsin farmers are navigating the complexity of cover crop implementation. So now I'm going to give a brief history of the project. As I mentioned, the project started in 2020 when the Soil Health Alliance for Research and Engagement, or SHARE, conducted a survey to learn more about Wisconsin farmers' information needs regarding cover crops. So SHARE surveyed around 90 agricultural educators in Wisconsin to learn more about how educators viewed farmer interest, knowledge gaps, as well as perceived barriers to the use of cover crops. And out of the 90 respondents, 62% indicated that they did not have sufficient locally specific information on cover crops to answer farmer questions. So that's what we're seeing in the orange bars on this graph. Statewide folks were about 82% more likely than those working in specific geographical locations to indicate that they lacked this sufficient information to answer farmers' questions. So that's this first group of bars. And The East and the North also lacked sufficient information to answer farmer questions compared to the South and the West. So, there were definitely some geographical regions that could use more support. So with these survey results in mind, SHARE launched the Wisconsin Cover Crop Citizen Science Network in fall of 2020 to respond to a lack of locally appropriate information about covers. The project really consists of two main components. The first is an online survey about cover cropping practices and farming practices more generally. And the second includes a biomass sampling component. And the citizen science approach, again, involves many participatory elements, including gathering and using farmer feedback in the survey design, supporting extension staff in networking with farmers, as well as producing individualized reports for farmers, annual summary, and opportunities for farmers to share results with other farmers. So in the first year of the project, there were 15 farmers covering 13 counties. In year two, 26 farmers covering 19 counties. Year three saw 58 farmers covering 28 counties. Last year, which was year four, saw 49 farmers covering 61 counties. So to date, over 100 farmers in over 60 counties have participated in the network, many for several years in a row. And hopefully we'll see some of you or the clientele that you work with join us for year five. All right, so when you join, what exactly are you getting into? I'll kind of give a brief project overview now. So participants are recruited in the summer, which is right around this time of year, coincidentally, to join the project, typically through extension agricultural educators, producer-led groups, land and water county conservation offices, and hopefully some of you out there in the audience today. Participation in any part of the project is completely voluntary. If you just want to complete the agronomic survey, that's great. If you're able to go out and collect some biomass, hey, that's even better. So participating producers complete an online 35-question survey regarding their cover cropping experiences that includes questions about agronomic practices, but also some more like open-ended questions geared more towards understanding the external and internal factors influencing cover crop adoption and implementation. Participants also collect a fall biomass sample around November, and new in 2022, the biomass samples were submitted for nutrient and forage analysis. And the overall goal of this data is to gauge cover crop biomass production, nutrient uptake, and forage quality to start building a Wisconsin-based data set for future analysis. And new starting this last year, participants also collected a spring biomass sample prior to termination or grazing of the cover crop to gauge spring growth and better understand changes in nutrient quality and forage quality. We asked that folks sample the same field in the fall and the spring. All right, so a bit more information on the survey here. Participating farmers complete an online survey of agronomic and cover crop practices to identify some common management strategies across Wisconsin's really varied soil and climatic regions. So the survey includes questions about rotations, soil texture, cover crop species, manure application, tillage practices, cover crop seeding methods and rates, cover crop termination methods and timing, as well as seed costs. We also include several open-ended questions, asking things like, for example, please share any details regarding establishment, growth, or management of cover crop species. Are there any interesting experiments or failures or equipment challenges that you're encountering? Really giving participants an opportunity to really share whatever they want with this team. We also collect background information, including things like the number of years of experience participants have with cover cropping, as well as the percent of their farms that are in cover crops. And as mentioned previously, the survey is continuously refined each year based on participant feedback, again, highlighting the participatory nature of the whole project. All right, so just a little bit of biomass collection overview. So for biomass collection, each participant is actually provided with a biomass collection kit that includes a scale to weigh biomass in the field, as you can see in this picture here, biomass clippers, bags to mail samples, again, for forage and nutrient analysis, submission paperwork that is pre-filled, trying to make everyone's life easier, an instruction checkoff list as well, and a PVC quadrant to guide the biomass collection. So basically, we ask folks to go out into the field, randomly place the 2x2 foot quadrant, cut biomass within the quadrant using the provided clippers flush with the soil surface and weigh in the field. Then some of the biomass is placed in one of the envelopes to be shipped for nutrient analysis. Remaining biomass placed in the envelope to be shipped for forage analysis. All envelopes and submittal forms, again, are pre-labeled, filled out beforehand just to make the process as easy as possible. We also asked participants to collect 3 photos showing the cover crop biomass at the time of sampling. And we also asked folks to measure the height of the cover crop near where their sample was clipped in the field. We send clear directions to all participants with their kits. And there's also a really great comprehensive YouTube video online featuring my colleague, Dan Smith, that walks participants through the entire process. So you make sure to check that out. And I think the link should be available in the chat. And so participating farmers receive a $100 stipend, their individualized results on cover crop biomass, nutrient analysis, and forage quality, as well as reports that are highlighting the yearly findings of the project. So a little bit about the annual reports. The annual project reports include things resulting from the survey as well as biomass results. So I pulled an example of what the 2022 report here is showing as part of the table from the report. I'll just kind of briefly walk through the columns here. So again, it shows the county of the participating farmer, the crop that preceded the cover crop, the type of cover crop, the seeding method for the cover crop, planting date, cover crop biomass, date that biomass was collected, and then things like precipitation, growing degree units, and the method of cover crop termination. So some really great information there in the annual reports, again, all contextualized by region. And so another way to explore project data and learn from, participating farmers, maybe in your county or region or more statewide generally, is through the recently launched online data dashboard. So the online data dashboard allows farmers and anyone interested really to see the data and the information about cover cropping practices from other participants in the same or nearby counties, or again, statewide if you desire. And I really think this is a great example of how the citizen science model in agriculture can be used to expand understanding of how data can be useful to farmers interested in innovative practices. And these data really begin to provide needed information on local practices and experiments around cover cropping in more areas of Wisconsin. And this farmer provided data includes, again, information on cover crop species and is contextualized, like we saw with that table previously, with information about planting dates, nutrient management, and tillage. And so now I'm just going to take a few minutes to explore the data dashboard with everyone. So I'm going to try the risky thing of exiting my presentation and bringing up our data dashboard. Toward West Brewster Street. So hopefully everyone can see this here. This is the website that hosts the data dashboard. So we've got a map here, some cover crop data graphs. This is where participants would go to fill out the survey for the 2024 season. And this is also an area or a place where you can register for the project. All right, so let's dive in a little bit here and explore our interactive map. So what you're seeing here, all these points are data points from participants that have been a part of the project over the last 4 years. So there are several different display options that you can use. And one really useful tool here is hovering your mouse over this, blue eye. And this gives you a little bit more information about what you're looking at on the display options, as well as some of these filters, which we'll touch on in a second. So right now, the display options include cover crop biomass, cover crop types, growing degree units, planting season, the prior crop, and relative forage quality. Filters allow you to select what you want to view based on the year. So for example, 2023, we can view the most recent data from the project. You can also filter by like soil texture or prior crop. So if you're on a silty clay loam or let's say a silt loam soil, and you want to see what other folks that have the same soil type are doing in terms of their cover cropping, you can select that filter, and it'll just filter people with silt loam soil textures. Again, prior crop, tillage type, seeding method, and even cover crop species. You can select all of these different things just to kind of whittle down the information that you'll be looking at. You can also select crops that had manure applied prior to the cover crop, manure applied post cover crop. And you can even filter for some points with photos, which we'll touch on in a second. So one thing I like to kind of show off here is changing our display options up here to cover crop types. And so you can see our different cover crop types in the key here. There are different colors. For example, the cereal rye shows up in this dark green. Light green is a mix of legumes, grasses, and a brassica. And so what you can see right away is looking at this map, which I think is really cool, is like, wow, there's a lot of different cover crop diversity in the state of Wisconsin. You know, folks planting annual ryegrass, multi-species mixes, you know, the classic cereal rye, but there's a lot of different diversity in our cover crops. Another thing I think that's really interesting to point out is if you look up here in the northern part of the state, specifically the northwest part of the state, you see that folks up here are having some success with their cover cropping efforts despite the shorter growing season. Another nice feature of this data dashboard is the ability to zoom in on a county. So we'll take Barron County here, for example, and we'll kind of zoom in on Barron County. And this allows people that are participating in the project, or if you're just interested in this kind of information, to actually look what's happening in your county, in your region. You know, what is your neighbor doing out there? You can find out a little bit more information by clicking on each of these dots. So for example, I'll click on this dot right here. Tells me the type of cover crop that was planted. As you can see, this is this lighter shade of green, indicating that it's a multi-species mix. It'll describe the seeding rate, the seeding method, the prior crop, planting date, again, that soil texture, and the biomass of this cover crop. And then we're working on this right now, and this should be present for most of our dots here, but we're just getting it going. We're going to have photographs that are associated with the cover crop at the time of that fall biomass collection. So you can see here, you know, this is what 1 ton of dry matter per acre looks like at the time of this biomass collection with this multi-species mix of wheat, vetch, and clover. So kind of zoom in here on another county here. We'll look at Calumet County. You know, one thing that jumps out to me right away when just kind of exploring this is, oh, there's some more, you know, diversity of cover crops here in Calumet County, mostly multi-species mixes in Barron County that we just looked at, but here we're seeing more diversity of cover crops. For example, some cereal rye grown here, some Dutch clover following, I believe this is corn for grain. So you get to get an idea of, you know, prior cover crops in, you know, specific counties. And it gives a chance to just explore a little bit more. Again, we've got some pictures here that are associated with these data points. More of those are going to be coming in the future. And just to show a little bit of how the display changes here. So instead of looking at cover crop types, we're going to look at our prior crop. Again, we can see that, you know, these multi-species mixes were largely preceded by wheat, which is maybe not such a surprise, but we look down here, you can see, you know, there's some corn for grain shown in the yellow, some corn silage shown in red, and soybeans shown in this lighter blue color. So again, just offering opportunities to explore a little bit more about what's happening in your county specifically, or, you know, statewide as well. So I highly encourage folks to check that out. In the interest of time, I'm not going to go over the graph as much, but I'll just show it here. Again, there are these filters that you can use. These information buttons can be really useful in terms of figuring out what you're kind of looking at here. And basically what this graph is showing on the y-axis, we're looking at our above ground cover crop biomass. And you can relate that to different things here on the x-axis, like total precipitation, growing degree units, and planting date. And another kind of neat thing about this graph is, you know, you can kind of get an idea of, you know, hey, who is this data point up here with 4.1 tons per acre of dry matter? Well, click on that point. That's a grower in Iowa County that planted a multi-species mix of 2 species or more, and a seeding rate of 25 pounds per acre. So just another way to explore a little bit more data from this project, and it's really accessible to everyone that's out there. So yeah, I highly encourage you to check out that data dashboard. It's pretty fun. You can spend some good time on there. So as we continue along in the presentation, how about a bit more data? After 4 years of the project, there are a few general trends that I'd like to highlight here. One interesting trend that is apparent from our data is that cover crop biomass in northern counties is competitive with farms in southern counties. So here where the y-axis is showing tons of biomass per acre, and the x-axis is showing different regions by year. So despite the shorter growing season in northern Wisconsin, farmers utilizing cover crops there are able to produce biomass comparable to our southern counties. So another interesting trend shows that manure application matters and can play a role perhaps in producing more cover crop biomass. So again, we're looking at biomass on the y-axis and our different manure applications, either yes or no, across the 4 years of the project. And cover crop fields that received manure before or after seeding had biomass production that outperformed fields that did not receive manure. So a few other trends to quickly highlight throughout the years. Multi-species mixes are increasingly popular, although several participants still focus on cereal rye. Multi-species mixes were the most common cover crop grown in the 2023 season. Most farmers use a drill to establish their cover crops. Neighbors and producer-led groups are consistently the top sources of information on cover cropping, and personal experience also plays a really big role. And finally, the average fall cover crop biomass for the last 3 years has been increasing, which could be due to a variety of factors, but I think may also suggest that participating farmers are fine-tuning and refining their methods to allow for increased biomass production. And so as I start to conclude here, I'm just going to run through really quickly some of the future project goals. One big goal is to link this data with other researcher-produced data from long-term studies to start really building comprehensive statewide databases. And if you are a researcher that is interested in accessing these data, you can reach out to any of our project team members and we can work with you to make that happen. So we are also interested in adding a soil health component to the project. We are developing resources to support farmers in interpreting the RFQ and nutrient analysis tests that we provide to them. Again, we're adding some more pictures to that data dashboard that are associated with sites so we can have some visual learning incorporated into our data dashboard. We're also using we're also calculating percent ground cover data from our biomass sampling photos, and then calibrating the amount of cover and biomass to the height of the cover crop. So some long-term and short-term goals just to share with you. And so as we wrap up here, I hope this presentation has really sparked your interest in joining the project. As I mentioned, registration is open, and we are especially looking for participants in underrepresented parts of the state. You can really see in this red square, we need some more beautiful, colorful dots. So we're especially looking for people in northern Wisconsin and the Central Sands. So keep that in mind as you're thinking about joining this project. All right, and so I'm just going to end things here by bringing it back to citizen science. One of the goals of this project was to learn how to supply data back to farmers in ways that support them in taking action. So specifically supporting ongoing local innovation with cover crops. And so if you see ways that we can improve, please let us know. The feedback is always appreciated. And again, the citizen science approach utilized by this project has generated informational, educational, and social benefits, including engaging farmers in on-farm research and successfully identifying locally appropriate cover crop management practices across Wisconsin. The citizen science element is key to the continued success of this project, and I sincerely hope some of you are able to join us for year 5 and onward.